Hey Harbor students and anybody else watching this. Today we're working on the sum and product factoring assignment. We're going to work on 3 different skills: the X game, factor trinomials where a equals 1, and factor trinomials where a is greater than 1. So make sure that you log into your Delta Math account, type in the teacher code, and click on the assignment. So the X game, as the name implies, is like a game where you have a graphic organizer and you're looking for 2 numbers that multiply to the value on top and that add to the value on the bottom. So in this example, 2 numbers, multiply them together, you get 24, and add them together, you get 11. So to do this, you're going to have to start by making a list of factors that multiply to 24. I like to create this little table here on the side. Now the best way to do this is to start with 1. So our factor of 1 times 24 equals 24. 2 times 12 equals 24. Now I happen to know that 2 times 12 equals 24, and that 3 times 8 is 24. But if you're a little rusty on your multiplications, you can use a calculator. For example, if my next factor is 4, I can do 24 divided by 4, which equals 6. And you're only using integers, so if you get a decimal, just ignore it and move on. Now, if you multiply 2 negative numbers, you also get a positive number. So you also have to include the negative numbers in there. Negative 1 times negative 24, negative 2 times negative 12, negative 3 times negative 8, and negative 4 times negative 6. Now which one of these, when you add them together, equal 11? Bingo. 3 and 8. So there's your answer, 3 and 8. In the next 2 slides, we're going to learn how to factor trinomials using a method that some people call the diamond and box factoring method, or we could call it the X games method. Doesn't matter what you call it, as long as you understand how to fill out this chart right here. So let's go over some vocabulary first. So a trinomial is an algebraic expression which has 3 terms. In this example, our first term is x squared, our second term is negative 11x, and our third term is positive 28. And if you were to graph this function in your graphing calculator, it would look like a parabola, like this. Now, when you're factoring trinomials, you're taking this expression, which is in standard form, and you're converting it into factored form. So let's rewrite our trinomial expression here at the top. We have f of x equals x squared minus 11x plus 28. Now notice that there's no coefficient a in front of the x squared, which means that the coefficient is just 1. This makes it a lot easier to factor a trinomial. In the next slide, we're going to look at factoring trinomials where the coefficient a is greater than 1, which is harder. But for now, we'll just ignore the 1. We can erase that. And we can also ignore this box. So from here, we just fill out our X games box. So the C goes on top. I'm going to put 28. And the B goes on the bottom, negative 11. We'll leave out the X's for now. So what are 2 numbers that multiply to the value on top, 28, and add to the value on the bottom, negative 11? So let's make our list of factors. We got 1 and 28, 2 and 14, 3, nope, doesn't work, 4. If you don't know these multiplications, you can just take your calculator and do 28 divided by 4 is 7. 5, no. 6, no. Yeah, that's it. But we also know that if you multiply 2 negative numbers together, you get a positive number. So we have negative 1 and negative 28, negative 2 and negative 14, and negative 4 and negative 7. Now, which one of these, when you add them together, add up to negative 11? Bingo, you got it. Negative 4 and negative 7. So those are the two numbers that are going to go here and here. And those are going to be the magic numbers that go into your binomial factors. So when you're writing your final answer in factored form, you're going to have f of x is equal to x minus 4 times x minus 7. And if you FOIL this out, you'll find that you do, in fact, end up with the same expression, like that. But the more interesting thing you can tell from this factored expression is the roots of the function. If we set this whole thing x minus 4 times x minus 7 as equal to 0, that means that either x minus 4 equals 0 or x minus 7 equals 0. Add 4 to both sides. Add 7 to both sides. That gives you x equals 4 or x equals 7. And notice that these are the points where the graph intersects with the x-axis. And we call these numbers the roots, or the real zeros of the function, 4 and 7. And that actually tells you a lot more about the function than when you're just looking at it in the standard form. In this slide, we're factoring trinomials again, except we're looking at an example where the coefficient in front of x squared is greater than 1. In this case, it's 5. So let's rewrite our trinomial up here. F of x equals 5x squared. Sorry. Let's make this red. 5x squared minus x minus 4. And because this minus x is on its own, we can even write in that it's minus 1x. And because it takes a little longer to factor these kinds of trinomials, I'm providing you with a guide over here on the left, which shows you the flow of the steps that you need to take. And if it doesn't make sense to you now, don't worry. I hope it'll make sense to you later. But you can kind of think of it like a flow with a snake that's following this path. Okay, let's get started. First, you're going to fill out the bottom left box with the value for ax squared. In this case, it's 5x squared. Then you're going to fill out the top right box with the value for c, which is negative 4. Next, you're going to multiply these two together and put the result of that into the x game. So 5 times negative 4 is negative 20. And then we're going to put our value for b in the bottom part of the x game, just like we did in the previous example. Notice that I left out the x squared and the x. They should be there, but it doesn't really help us with the x game, no pun intended. So we'll just ignore them for now. So what are two numbers that multiply to the value on top and add up to the value on the bottom? Let's make our list. We have 1 and negative 20, 2 and negative 10, 3 no, 4 and negative 5, 6 no, 7 no. Yeah, that's it. But then you also have the inverse. So negative 1 and positive 20, negative 2 and positive 10, and negative 4 and positive 5. Which one of these add up to negative 1? 4 and negative 5. So we'll write those here, 4, negative 5. And now instead of writing those directly into our factored form, we're going to put these into these boxes. So I'm going to write negative 5 and 4, and this time we're going to include the x's. So now, in this space right here, we're going to look for the greatest common factor between 5x squared and negative 5x. Another way to think of it is, what do 5x squared and negative 5x have in common? Well, they have a 5 in common, and they have an x in common. And from here, it's kind of like a game of Battleship. So what do I need to have here in order to make 5x squared? So 5x times x is equal to 5x squared. Okay, now what do I have to have here? 5x times -1 is equal to -5x. What do I need to have up here? X times 4 is equal to 4x. And then for good measure, you just make sure that whatever is here times whatever is here is equal to -4. Yep, -1 times 4 is -4. So we are in good shape. So these are going to be your binomial factors. On one side, you're going to have 5x plus 4. And on this side, you're going to have x minus 1. Now that's all you need to do to convert standard form to factored form. But if you're interested in finding the roots and graphing this, what you can do is set this expression equal to 0. And then solve for each binomial factor. So 5x plus 4 equals 0. I'm going to subtract 4 from both sides. 5x equals -4. And then divide both sides by 5. So your roots are going to be -4/5 or x minus 1 equals 0. Add 1 to both sides. X equals 1. And the graph looks like this, where you see the roots, or the real zeros, at -4/5 and 1.